Well, the world is producing hydrogen propulsion systems to stop the emissions caused by gas turbine engines or conventional propulsion systems. Emissions such as carbon dioxide, nitrous oxide, and we're gonna build a green earth, right? Not quite. We still got some challenges that we need to overcome before installing a hydrogen propulsion system into our aircraft. These challenges can be from costing, and storage, and even design. That's why if you see Airbus zero emissions program, those aircrafts look much more different to our conventional aircrafts. So in this video I'm going to talk about those challenges, and maybe some of you can look into them in your researchers or PhDs if you're planning to do one. Before going to intro, my name is Dinwan Galvatta and you're joining with the Aero Technicians YouTube channel. It's a aviation 6-pack and the aircraft and the sub. So let's kick off with number 1, storage and transportation. Well, hydrogen has lower energy density compared to other fuel. Well, what does energy density means? Energy density is the amount of energy stored in a given system. So when something has lower energy density, it requires larger storage tanks to be manufactured to store the same amount of energy as the normal fuel. Let me simplify this for you. If the traditional aircraft requires this much of energy to travel from point A to B, because of hydrogen, it will require something like this. So when larger tanks are required, it's gonna affect two things in a traditional aircraft. One thing is the space for passengers or any other cargo that the aircraft is carrying, and it will increase the size of the storage system, which is increasing the weight of the aircraft. And also traditional transportation trucks and pipelines can't be used to carry hydrogen, so we need new transportation systems to carry hydrogen, which means we need new transportation trucks and new pipelines. So that's the first challenge: storage and transportation. Number 2, safety concerns. So I've picked up 3 main concerns that needs to be addressed before introducing hydrogen propulsion systems. I mean, I'm pretty sure there are a lot more than 3, in which case please drop them down in the comment section so we all can learn from them. So the first point I want to discuss is hydrogen is extremely flammable, which is something to look at. So the second is handling and storage of hydrogen will require extra attention. And the third bit is the combustion of hydrogen is a lot more different to the combustion of our normal fuel, which will require newer safety protocols. So these are the 3 I think which needs to be addressed mainly when we start this process of transferring conventional gas turbine engines into hydrogen propulsion systems. So let's look at number 3, costs involved with hydrogen. There are 3 things to look at: the production, the storage, and the distribution. If you take production, new fuel cells will be manufactured for this process, which can be expensive. And storage, as I said earlier, newer storage technologies has to be introduced. And third, distribution. Again, as I mentioned earlier, we will have to take into consideration how we're gonna transport hydrogen. Is it by designing new trucks or newer pipeline systems, or using both? And I think cost is one of the biggest challenges we need to overcome as aircraft engineers. So if you're a PhD or a master's student, a good idea would be looking into these factors if you're interested in hydrogen propulsion systems in your research project or your thesis. Number 4, limited availability. Now, we all know from our 6th grade chemistry lesson that hydrogen is the most abundant element in the periodic table or in the universe, which is true, but it is not available in its free form. So, we might have to extract it from compounds like water and other hydrocarbons. So, there is a limitation when it comes to hydrogen. So, our 5th challenge is hydrogen combustion, and the $1,000,000 question: can we completely stop the emission of harmful greenhouse gases? Let's look at the combustion process. So pure hydrogen is combusted with oxygen in order to give out water vapor as a byproduct. Now this oxygen is not in its pure form. It is mixed with nitrogen. So one other thing which is given out with water vapor is nitrous oxide. Let's not forget, nitrous oxide is 300 times more potent than carbon dioxide, and it also depletes the ozone layer. So have we completely stopped the emission of greenhouse gases? Well, I'm not degrading the hard work of our fellow engineers, and I'm definitely not saying hydrogen is not the solution for the problem. But we have managed to stop the emission of carbon dioxide, which is a great win, and we will somehow find a way to stop nitrous oxide. This video is to raise awareness and to encourage students and engineers like you and me to help find solutions to some of these challenges and contribute to the greater cause of reaching net zero in the future. So hope you enjoyed the video. If you have any questions, concerns, please drop them down in the comment section and give it a thumbs up. If you think this video carries any importance, share it with your connection, educate them, which will also keep me motivated to do more videos like this. Before I forget, I made a video last week about aviation sustainability. I'll drop it somewhere around the screen. And as always, I'll bring a new video next week. Till then, keep fixing.